Imagine stepping into the cockpit, that incredible machine, responding to your every command, becoming a pilot, earning those wings. It's a dream for so many. But before you get there, there's this, well, mountain of knowledge to conquer, especially those ATPL theory exams. At its core, aviation is this mesmerizing high-stakes dance between humans and some of the most sophisticated machines ever created. Today, we're really going to deep dive into that dance. Our mission for this deep dive is to extract the most crucial information from our sources on man and machine, flight deck design, and automation. Now, think of this as your shortcut, really, to understand the complex interplay that not only keeps planes safely in the sky, but also prepares you to, well, nail those key questions on the human-machine interface.
And this isn't just about passing an exam, although, it's certainly structured to help you do that. Understanding how humans and machines interact in the cockpit is, well, fundamental for real-world safety and operational efficiency. We're going to dissect the core principles that dictate how you, as a pilot, interact with modern aircraft systems, pulling out those essential insights that truly matter for both your exams and your future career.
Okay, so if we're going to truly deep dive into this human-machine dance, we need a framework. And at the heart of understanding human factors in aviation is a foundational concept known as the shell concept. It's a brilliant model, actually, first proposed by psychologist Edwards back in 1972. It helps us see how every piece fits together in the cockpit ecosystem.
Exactly. It's an acronym, SHELL, and the beauty of it lies in how it systematically breaks down the elements. At the core, you have the two L's. The central L stands for Liveware, and that's you, the pilot. You're considered the most valuable and flexible component of the entire system. Then the second L represents other Liveware, so that's other humans. Could be your fellow crew members in the cabin or people outside the aircraft, like air traffic controllers. Then we kind of expand outwards from there. S is for software. Now, this isn't just computer code. It covers everything from procedures and manuals to, the precise layout of checklists, the symbology on your screens, even maps and charts, all that procedural stuff. Next up, H stands for hardware. This covers the physical design of the flight deck, the aircraft structure itself, how instruments are presented, and importantly, the positioning and operational sense of all the controls, the physical bits. And finally, E is for environment. This refers to all the conditions, both inside and outside the cockpit. Think pressurization, soundproofing, temperature, humidity, vibration, that sort of thing.
That makes so much sense. So taking the shell concept, how does something as, well, seemingly simple as a pilot reading a checklist fit into this model? What's the key interplay there for, say, an ATPL question?
That's a perfect illustration of shell in action and exactly the kind of thing they might ask. The checklist itself is clearly software. It's the procedure, the specific layout, the information, and you, the pilot, are the liveware at the center. So the question, a pilot is reading a checklist, in what way is this a reference to the shell concept?
Yeah.
Really points to that direct interaction between software and liveware. The insight here isn't just that they interact, but that the quality of that interaction, how clear the checklist is, how focused you are, is absolutely critical. It highlights how that software impacts the human element.
Right. And if that software to liveware link isn't seamless, isn't clear, that's precisely where you start seeing the potential for human error impacting safety. Okay, with that shell view in mind, let's zoom in on a very tangible part of the hardware aspect, the physical flight deck itself. Specifically, how it's meticulously designed around you, the pilot. We often hear about the eye datum, sometimes called the design eye position or reference eye point. Why is that so crucial?
Oh, it's absolutely fundamental. It's a precisely defined position for your eye that ensures you can see all the critical displays inside the cockpit and maintain an adequate view of the outside world, all with minimal head movements. You'll often find a little indicator, maybe physical markers, in the cockpit that only align perfectly when your eye is at this precise point. It sounds simple, but it has profound safety implications, especially during high workload phases like approach and landing.
Okay, so on approach then, if you're not at that design eye point, what's the consequence? Like if you're seated too low, what might you lose sight of? That's...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.